Kayla's here. Okay. Anyone else come in since I called roll? Okay. All right, let me go over just a couple of announcements. I think you've heard them all before. Well, yeah, I can't remember if I did this one or not. I've seen posted on the walls, and I'm sure I must have gotten one in the email. I haven't found it yet. There is a special performance scheduled for tomorrow morning, 9:30, on the Birmingham East Campus in the A.G. Gaston Auditorium. A troupe from UAB's music theater type department will be there and performing Broadway hits. That may sound a little dull to you, but actually I bet you they're fantastic singers, and I bet you it's going to be a pretty lively performance. So highly encourage all of you to go. I wouldn't be surprised if any of you might be in a humanities course, and they may be requiring it or maybe giving extra credit for it or something like that. So if you are in any kind of art or humanities course, you might check with your instructor and see if you can maybe weasel some extra credit out of it if you can. So that's tomorrow morning, 9:30, Birmingham East Campus, A.G. Gaston Auditorium. Should be quite good. All right. Then the thing about graduation, I know probably most of you are probably not that close, but keep in mind the time to apply to graduate is not the term you're going to graduate, the term before. Huh? 3. Oh, no? 3, okay. Yeah. Got you. There you are. Okay. I have 2 Brees in another class, and I said, "You're not one of them." And I realized I'm in the wrong class. Okay, or in the right class, but wrong. Okay, so please remember to apply to graduate the term before you're scheduled to graduate. Start the process early. Take a look at your degree plan, go over your degree plan with your advisor, get it all set up, and then when the registration opens for that next term, make sure that you can get all the courses that you need. If you can't, start the process of trying to get that course open, the one that you need, or get a course substitution approved. And you can do that all the term before, and then when the term gets there, you're registered for exactly what you need to graduate, and you can zoom through without any problems. If you wait till the term that you are scheduled to graduate, and then you can't find a course scheduled, then you may wind up taking a course the next term. So please try to get that done sooner rather than later. And Ron decided to show up today. Oh, I'm sorry, he's here. Okay, good deal. Okay, also they're looking for note takers. Assume either campus, but certainly on the Birmingham campus, they'll pay you to take notes for a student who has some reason they can't take notes. So please consider doing that. Great service to someone else, and you get paid to do it. And then also they're looking for tutors in the Space Center. I know math, English, biology, Spanish, and computer science. I know y'all are good in math, so you could do that one. You probably are good in other subjects too. And I've already got Demetric here. So it's a great service to someone who needs it. Also, it'll help you in that subject. Believe it or not, you'll learn the subject better than you ever did in class if you have to explain it to somebody else. And then on top of that, they pay you. So please, and it's not just Space Center on this campus. We also have student support services that provides tutoring as well. So check both of those out. And keep them in mind for next term as well. Any questions? Anything we've done up till now? This is a minor one, and it's in the future, but let me say it now while it's on my mind. I think I told you early in the term, at the very beginning, that I knew I was going to have at least one doctor's appointment on a Tuesday morning, because that's the only time my hematologist sees patients, okay? That's coming up not next Tuesday, but the following Tuesday, the 16th. And it'll be I think my appointment's at 10:40, meaning I have to be there for blood work at 9:40, meaning I have to leave campus by 9 o'clock. So that class We'll have most of the classes normal, but I just have to, well, we'll have half hour of class, okay? And then I'll be leaving to head to Kirkland Clinic. So it'll be an abbreviated class that morning, only about 30 minutes. Unless, of course, y'all want to start at 8. And, oh, you don't? Oh, okay. I thought, knowing how eager y'all were, you might. Okay. Thank you for not wanting to. Okay. All right, let's get going from the current slide. We're almost through with 1.9. And for some reason, everything has been incredibly slow this morning. Like there, I clicked on from current slide, and finally it shows up. Okay. Everything has been slow this morning. So I don't know what's wrong with the little computer karma today. Not good. All right, we're finished everything but the last example, and this one perhaps is a little bit of a doozy, so let's make sure if you know how to do this one, you'll probably be in pretty good stead for all of this type. So, and this is probably the toughest thing we've done so far in this section. It's the last thing we're doing anyway. All right, now, a little bit of review. We're finding an inverse function algebraically. Earlier they had us doing it by observation or whatever they called it, and that was a bit awkward, bizarre, and only can be done for very simple functions. Now we're in the real world where it's a bit more involved. There was a procedure that we discussed last time. Let's use that this time, or at least some version of it. So this was example 6. We did that one and the other example 6, the one from your text. We did finish that one last time, the second one, right? Yeah, I remember we did. All right, so let me get my pen activated. Okay, and let's do example 7. Find the inverse function of f of x is equal to the square root of 2x minus 3. All right, here's Tyler. All right. Anyone else come in since I called roll? Okay. Now, what's the first thing they suggest, good idea to do before you're finding an inverse of a function? Pretty smart move. Say again? Okay, we will be doing that, certainly. But the first thing you do is make sure it has an inverse. No reason spending a lot of effort if it doesn't have an inverse. Now, what's required for a function to have an inverse? It has to be a one-to-one function, okay? Now, they suggest graphing it. Do you think we might be able to get by without graphing it? Okay? Now, actually, I'm going to do a timeout here and say on a problem like this, there's something else I like to do first. Okay? And when you were mentioning square root, what were you thinking? You may have been thinking exactly the right thing. What was it? Okay. Right. Sorry about that. I shouldn't have cut you off. The main thing, when you see a square root, bells, flags should go up. Warning. What? No, you can't have 0 inside a square root. That's okay. Square root of 0 is 0. I can do that one. But what can't you have inside a square root? Negative numbers. So therefore, this expression here, 2x minus 3, 2x minus 3, that's what's inside the house there. If it can't be negative, what must it be? In math speak. Yeah. I'll get your name, please. Deja, got it. Okay, yeah, you're telling me what to do, but what What symbol do I need there? Greater than or equal to 0. If it's not negative, it's got to be greater than 0, right? If it's not negative, it has to be positive. Not greater or greater than or equal to 0. Now, I think what you were suggesting, what do we do next? Yeah, or add 3 to both sides. Either way you want to do it. Subtracting negative 3 or adding 3 to both sides. And that wipes that out. So you get 2x is greater than or equal to 3. And now what? Divide by 2. And what does that give us? X has to be greater than or equal to 3/2. Perfect. Okay. Now, if you'll think about it with me for a moment here, when x is 3/2, that makes this exactly 0, right? 2 times 3/2 would be 3 minus 3 is 0. So that's starting at 0. And then as this number gets greater, as x gets greater, then 2x gets greater, and even 2x minus 3 gets greater. So this is increasing from that point on. Okay? Strictly increasing functions are 1-to-1. So we've done the first one without graphing it. Okay? And we've also done an important service here. We notice that your x has to be greater than or equal to 3/2. Okay. Yes?
You said every time it's increasing, it's 1-to-1?
A strictly increasing function is 1-to-1. A strictly decreasing function is 1-to-1. One that wobbles, waves, not 1-to-1. Okay. Remember the horizontal line test. Strictly increasing, it's going to pass it. Strictly decreasing, it's going to pass it. If it goes up and down, it's going to fail. Okay. So, all right. First step done. It is a 1-to-1 function because it's strictly increasing. Where do we go from there? Help me. Okay, it's my mantra for the course. Remind me? Evan. Got it. You try it, right? Okay. All right. What's next? What's the thing I always ask you? What is this? Okay, you change your f of x to y. Perfect. Okay, y is equal to the square root of 2x minus 3. Done. Now what? Yes, very good. Okay, exchange x and y. X is equal to what? Square root of 2y minus 3. Perfect. Next. Say again? You got to get rid of that square root sign. That's the messy thing here. How do we undo a square root? Okay? Square. And if you square both sides, what does this give you? X squared is equal to 2y minus 3. Perfect. That removes the square root sign by squaring both sides. Now what? Add 3 to both sides. What we're doing here is solving for y, our new y that we exchanged. Whoa, get out of here. Okay, here we go. Okay, so we'll add 3 to both sides. So that gives us x squared, add plus 3, I can't talk, is equal to 2y, because that adds a 0. And now what? Divide both sides by 2. Okay, now I'm going to rewrite it slightly and write that as y is equal to x squared plus 3 divided by 2. Okay? Now, not quite the last step, but awfully close to it. What do we do now? What is that? That's your inverse function. So you change the y not to f of x, but to f inverse of x. And the reason it's f inverse is because we exchanged the x and y. So this is equal to x squared plus 3 over 2. Excellent. Now, what's the last step? The one we always look forward to, checking it. Okay, how do we check it? Say this again. You don't want to do it, I can tell. Okay. So, what do we do even if you want to or not? She's going to fold her arms. No, I'm not going to do it. Okay. It's f of f inverse of x. Okay. Now, what's that? Whoa, get out of there. Huh? What's that? It's f of, and what's your f inverse? Just above us there. X squared plus 3 over 2. And what does f tell you to do with that? Okay? Yeah, we're going to start with your square root sign. That's the first thing f tells us to write down, right? And then we're going to get a 2. But the x, that's what was in parentheses here. What's in parentheses there is x squared plus 3 over 2. And then the last thing we do is subtract 3 from it, all under the house there. Okay? Now, what can we start doing now? What do you notice? The 2's go out. 2 over 2 is 1. And then the 3's go out. Plus 3 minus 3 is 0. And then the square root of x squared is x. Ding, ding, ding. That works. Okay? Now, I know that you're looking forward to doing the reverse of it. Yeah, you're not. But let's try it anyway. I don't know if I have room to, so I'm going to start up here. If I need to, I'll start erasing. This time, what do we do? F inverse of f of x. Okay? And which do you plug in first? The f of x, which is the square root of, the f of x is this. Okay? The square root of 2x minus 3. Okay? There it is. And what does f inverse tell you to do with that? Here's your f inverse, by the way, in case you lost it. You start with that entity, the square root of 2x minus 3, and you square it. Then you add 3 to that, and then you divide that by 2. Okay? That's what it tells. Cameron, right? Okay. I'm sorry?
Did I miss anything Tuesday? Did I miss anything Tuesday?
Of course you did. You think we did nothing?
Well, like, did I miss any handouts?
No, I didn't. Yeah.
I did all of them.
Yeah. All right. All right. I've got to stand on here. All right. Is anyone else come in since I called roll? You didn't hear me acknowledge your presence. Okay. Now, I can't remember if I've said this before, after anyone else came in, but let me reiterate one thing. Not important, not coming up real soon, but a week from Tuesday, the 16th, we'll have a fairly short class, 8:30 to 9, because at 9 o'clock I have to leave to go to the doctor's appointment at Kirkland Clinic. So it'll be a fairly short class that Tuesday. Okay. Now, another thing, and for people who weren't here last time, we came that close to finishing the chapter, so today we will finish it, knock on wood. But, not that funny, okay. Since we will finish the section and the chapter, that means the test will be Tuesday, okay? That means the quizzes have to be in, preferably today or tomorrow, or Monday, so I can get them back to you before or by Tuesday. But right now, I'm still missing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 quizzes. Okay? That's almost, not quite half the class, but awfully close. Okay, better than a third. All right, so what we're doing was doing f of f inverse. Okay? Now, what happens when you square that square root? They wipe each other out. The square root sign goes away, and the square goes away. So that gives you a 2x minus 3 plus 3 over 2. And what do you notice now? right here. Okay? The 3's go out. They've been dating. Okay, no. Okay. They add the 0. And the 2's go out because those divide to 1. And what do we have? X. Okay, sorry about that. And when you get X the second time, you know that you must have done it right. Okay? These are the inverses of each other. Now, another time out here. Okay. We know that the X for the original function here has to be greater than or equal to 3/2. What does that tell you about the inverse function right here? Okay, the output of this has to be greater than or equal to 3/2. How about the output of this one? What would that be? You take the square root of 2x minus 3. What kind of values do you get? Positive only, because this is a principal square root. So what does that tell you about the inverse function? Looking at this, I would say its domain would be all real numbers, but it's not. The domain of this must be all positive real numbers, because that's the range of this. And vice versa. With that in there, that then requires the output of this one to be greater than or equal to 3/2. Even though there's nothing looking at this that you would think would limit that, except looking at it, okay? Any X you put in, positive or negative, is going to come out positive. The smallest would be 0, and then you get 3/2, and then everything else is greater. So that basically pans out. You don't even have to worry about it. That domain, that range will be greater than or equal to 3/2. It's the domain of this is limited by the range of that. Okay. You don't have to spend lots of energy staying up at night worrying about that, but it's something to sort of keep in mind. All right. Any questions? Now, the other thing they did was show the graph. Huh? Alexa. Okay. I'll find them. There it is. Okay. And, it's Ashley. Okay. Anyone else come in since I called roll? Okay. Now, we already almost did the graph. We talked about the graph but didn't do it. So I'm going to erase enough space here. I don't know, maybe I should erase it all. Okay? Y'all remind me what our functions were. Okay? So our alpha of x was, okay, the square root of 2x minus 3, and our alpha inverse of x. I should put this in a different color. Someone give me a different color. Blue. Light or dark? Dark. Okay, we'll go with dark blue. This was x squared plus 3 over 2. Is that right? Okay, you better not be reading this. Okay. So, let's go back to black here. Okay. And I can draw this just first quadrant. Why? X, yeah, the y's for the first function are all positive, and the x's are all greater than or equal to 3/2. That means that for the second one, the y's are greater than or equal to 3/2, and the x's are all positive. So I only need the first quadrant here. So let's tick off a few points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, something like that. All right? Now, we sort of know where the first function does, alpha of x. It starts at 3/2, which is 1 1/2, and there it's 0. Okay? Now, these are not going to be super pretty ones to do. That's when that thing under the radical is 0. The thing under the radical when it's 1 that would be 2x minus 3 equal 1. Add 3 to both sides. 2x is equal to 4. Okay? And divide by 2, your x would equal 2. So when x equal 2, we're here at 1. Okay? I want the thing under there to be 4 now, because I can take the square root of 4. So when that's 4, add 3 to both sides, that gives you 7, and x would then be 3.5. Okay? 1, 2, 3.5, and that would be 2 here. Okay? And then when x, okay, the next one, I want what's under the radical to be 9. Okay? Add 3, you get 12. Divide by 2, you get 6. So x equals 6. 1, 2, 3, 4, 5, 6. That will give us a 3 here. Okay, right there. The next easy number to do under there, under the radical, would be 16, because I can take the square root of 16. So when that's 16, add 3 to both sides, it makes it 19. Divide by 2, and you get 9.5. So that's 6, 7, 8, 9.5. Thank goodness I don't need to do any more. No, I didn't say that, did I? Okay. All right. Something like that. Okay. Here's what it looks like. It's half a sleeping parabola. Kind of fat on the end, and that's because, yes?
So do you put the numbers in the radical?
Okay. I did because I was being lazy.
Oh, okay.
Okay. Rather than picking an x and then having to do a square root of 2/3 or something like that, which I don't know and I don't care for, I choose what I want under the radical. I put 0 there to begin with because we did that at the very beginning of the problem. I know the square root of 0. Then I put 1 under the radical because I know the square root of 1 is 1. And then I put 4 under the radical because I know the square root of 4 is 2. So I know what I want the answers to be, and I found out the x to give them to me. It's sort of backwards. It's open, I think. Did you like it when you came in? Why did you do that, huh? This one won. Okay. And it's all right, good deal. Anyone else come in since I called her up? Okay. So that's how I did it. Just
And like the
yeah.
points, like how do you determine the points in the graphic? You know, the bottom points.
Okay. I just took them off there. I didn't make anything. The first one I was going to deal with was x equal 3/2, because that's the very least it could be. We did that at the very beginning. So that's 1.5. And that was 0 there. The y is 0. And then I did what I was describing, make this thing equal to 1, so I add 3 to both sides, that makes it 4. 2 divided by 4 divided by 2 is 2, x equals 2, right there. That would be 1 here. Okay. I just did that because those are easy values to do. And so that's how I chose my x, by making this be things I can take square roots of. It was just my dumb way of doing it. You could just plug in numbers on your calculator and plot points and then you don't want to.
Thank you.
Yeah, but since I didn't have a calculator, I wanted to do it easy. All right. Now, next thing we're going to do is change color to dark blue, and we're going to plot that one. Okay? And this one, I'll just say the inverse function. Give me an x. 0. And what do you get? 1.5. 3/2. Right. Okay. Give me another x. 1. 1 plus 3 is? 4 divided by 2 is 2, which you knew the answer to. And yeah, okay. At 1 we get 2. Okay, right there. Okay. And here's Walt. Somewhere here. I know you're in. There you are. Okay. All right. Give me another x. 2. 2 plus the 2 squared is? 4 plus 3 is? Divided by 2 is? 3.5. So when x equals 2, you're up here at 1, 2, 3.5. Basically almost the same thing we were doing before. In fact, exactly like we were doing before. Give me another x. We did 1 already, did we? 3. We did 0, 1, and 2. So let's do 3. 3 plus 3 squared is 9 plus 3 is divided by 2 is 6. So when x equals 3, we're up at 1, 2, 3, 4, 5, 6. Somewhere about there. Okay? And another one. X equals 4. 4 squared is 16 plus 3 is 19 divided by 2 is 9.5, isn't it? That's 6, 7, 8, 9.5. That's as high as we can go. Thank you very much. That's at 4. So here is our parabola. Now, the question is, what does that seem like it's doing to you? Oh, get out of there. Okay? It's mirroring this line, your one-to-one line there. Oh, something like that. Okay? It's a mirror image across that line. You see it? I mean, my picture's pretty ugly. Don't like it, look in the book. It's a little neater. Okay? Good deal. Now, what I don't know is why they have the horizontal dotted line there. I haven't figured that one out yet, but it's okay. Whatever. Okay. Any question? That finishes, folks, all we're going to do in chapter 1. Finally. Okay. Let's do the vocabulary, top of page 90. If f of g of x and g of f of x are both equal to x, then the function g is the blank function of the function f. Inverse function. It's got to be. Okay? Number 2. The inverse function of f is denoted by, how do we write that? Yes, f to the minus 1. Just like that. F to the minus 1. That's how we write it. I probably should go back to black here. Okay. There. Okay. That was number 2. Number 3, the domain of f is the blank of f inverse. Range of f inverse, and the blank of f inverse is the range of f. Domain of f inverse is the range of f. Perfect. Number 4, the graphs of f and f inverse are reflections of each other in the line x equal y, y is equal to x, either one. That's exactly what this line here is. I think I'll go back to red to write it down. Okay? This line right here is y is equal to x, or x equal y. It's called the identity function. Okay? But that was what they wanted to do, x equal y. Okay. Or y is equal to x, doesn't matter. Number 5, a function f is blank when each value of the dependent variable corresponds to exactly one value of the independent variable. Exactly one value. 1 to 1. Excellent. Okay? And then number 6, a graphical test for the existence of the inverse function of f is the blank line test. What? Horizontal line test. Perfect. To be a function, it's the vertical line test. To be an inverse function, or 1 to 1, it will be the horizontal line test. Okay, homework exercises. You've been given most of these before. Let me go over them again. Any of the odds 7 through 13, they're all at Calc Chat, and they all have answers in the back of the book, by the way, too. But they're all at Calc Chat for worked out solutions. And number 9 is actually at Calc View as well, which really gives you more detail. Then do either 15 or 17. They're both at Calc Chat. 15's at Calc View. Do 19. It's at Calc Chat. Do any of the odds 21 to 31. They're all at Calc Chat. 23's at Calc View. Do 33. It's at Calc Chat. Do 35. It's at Calc Chat. Do either 37 or 39. They're both at Calc Chat. Do either 41 or 43. They're both at Calc Chat. 41's at Calc View. Do any of the odds 45 to 53. They're all at Calc Chat. 45's at Calc View. Do any of the odds 55 to 69? They're all at CalcChat. 61's at CalcView. Do any of the odds, now these get to be a little bit different from what we have been doing, but I think you can do it. Well, no, we kind of did this. Any of the odds 71 to 77, they're all at CalcChat. Do any of the odds 79 to 83, they're all at CalcChat. Do either 85 or 87, they're both at CalcChat. Do 89, it's a CalcChat. 91 is a true false, it should be at CalcChat, excuse me. 93, you should be able to do. I don't know if you want to, but you could. It should be at CalcChat. 95 is a proof. I think it's probably at CalcChat. Don't know if 97's there or not. You can check it out, but you can think through that one. And then 99, I'd say 97 and or 99. They're both, think about it. You can check them out at CalcChat. And then there's a 101 that you should be able to do. It should be at CalcChat as well. All right. Now, you notice there is one more section in Chapter 1. We're not going to do it. It's called Mathematical Modeling and Variation. It is a pretty important concept, but it's not something that was on the course description for this class, so you can read through that in case you ever need it anywhere else. I'm not going to assign any exercises. You could do some of them if you wanted to. That's completely up to you. There is a pretty good chapter summary that picks up on page 104, 105, okay? And this is by section. And if you recall, we started with section 1.4, wasn't it? Yeah, I believe so. So you can look at the information there. They show the summary for 1.4, 1.5, 1.6, 1.7, 1.8, and 1.9. Might not be a bad place to choose to get a lot of your stuff for your formula and equation sheet. Remember, you can have, notice this, folks, you can have during the test a piece of paper with anything you want to write on it, okay? Front and back, as big or small as you want to write, if you can read it, you can have a formula and equation sheet, anything you want to write down on that piece of paper, okay? And this would be maybe a good place to get some of that, at least sections 1.4 to 1.9, okay? Then there's a bunch of review exercises. These would be great practice problems for that, and they list these by sections. So you don't have to worry about 1.1, 1.2, or 1.3. 1.4 starts on page 107. And again, now I think in the back of the book, they may have all the answers to these. But at CalcChat, they only still do odd number exercises, okay? So you choose what you want to do. Any of 43 to 46, 47 or 48, 49 or 50, 51 or 52, 53 or 54, 55 or 56, 57 or 58, 59 or 60, 61 or 62, 62 or 63 or 64, 65 or 66, 67 or 68, 69 or 70, any of the ones between 71 and 80, 81 or 82, 83 or 84, 85 or 86, and 87, 89, or 87 or 88, 89 or 90, 91 or 92, and 93 or 94. Don't worry about the rest of it. Now, another really good thing to look at would be the chapter test. Okay, there's 26 questions here. Some of these come through from the first group, 1 to 1-3. You don't have to worry about those. The ones that picked up with the functions, where we start, is about number 10. Okay? So any of the problems 10 through 23 would be great ones to review. Now, again, the answers to them all are in the back of the book, even and odds. But at CalcChat, they're only the odds. So you can choose whether to just do the odds or, and you don't have to do any of them if you don't want to, but that would be a great review for the test. 10 through 23. All the answers are in the back of the book. The odd numbers are done at calchat.com, tutorial help and worked out solutions for those problems. The back of the book only gives an answer. All right, any questions on chapter 1? And frankly, I think the best way to study is doing that formula and equation sheet. You know, that you're going to have to decide what's important, you know, write down what it is. The act of writing is a very active form of learning rather than looking at it and saying, okay, I need to know this, I need to know that. That's really passive. Writing it down is a lot more active, okay? So I highly recommend you do that for the, I guess I've already done it, so discard. I just want to make sure there weren't any more slides after that. I'm pretty sure there weren't. Okay. Yeah, I know there weren't. All right. So we're through with chapter 1. Let's get started on chapter 2, 2.1. Now, everything was really, really slow this morning. Let's see if it's still as slow. I mean, I sat here for the longest time watching these little dots go across the page, waiting for PowerPoint to open. It's a little faster now, so maybe it awakened, okay? Okay. So let's go from current slide. If it'll do that. Okay. Chapter 2, chapter 1 was introducing you to functions. And really, we were all over the place. Functions in general, okay? Now, we did look at certain ones, but there were all sorts of them. Chapter 2, we're focusing on 2 types of functions. One of these is polynomial functions. This will be 2.1 through 2.5. We'll do with polynomial functions. And then 2.6 we'll do rational functions, okay? Seems like it's getting cheated a little bit, but you'll see it pretty much follows nicely, okay? So, we'll start in 2.1, even simpler than just polynomial functions, only looking at quadratic functions and models, okay? So, we will analyze the graphs of quadratic functions. I think you know what they look like, whether you realize it or not. We'll write quadratic functions in standard form. Well, wait a minute, haven't we been doing that? Not really, okay? We've been writing quadratic equations in standard form, but not the functions, okay? We'll use the results to sketch the graphs of functions. They love sketching, right? Graphs of functions. And guess what? This actually makes it easier to write it in standard form. And we'll find minimum and maximum values of quadratic functions in some real-life applications. All right, we're looking forward to that. So let's first look at the graph of a quadratic function. In this section, you'll study the graphs of polynomial functions in general, okay? But we're going to focus on quadratics. So here it goes back and reviews. Okay. What do we call that function? Alpha of x equals ax plus b. A linear function. You read it before, didn't you? Okay. What makes it a linear function? Okay, it graphs as a straight line. That's where they get the term linear. Okay, good. What, looking at that, can you tell me it's a linear function without looking at this? Okay. What's that? Okay, here. Okay, the exponent for your variable, 1 and only 1. Okay? That's what makes a linear function. What do we call that one? A constant function. Okay? What can you tell me about a constant function? Okay, let's go back to linear function. The graph of a linear function is going to be a straight line. And what does the A tell you? The slope of the line. If that A is anything other than 0, then if it's positive, it's going up, negative, it's going down. 0, that would be your constant function. Okay? And that has how many values? 1 and only 1 value, C. That's the only value the function has. Now, how about this one? What did we call that one? Had a couple of names for it. It's what? The squaring function is also, could be called your parent function for all your quadratic functions. Okay? Now, those are just 3 examples of polynomial functions. Polynomial functions, what are the rest of polynomial functions? What can you tell me? Here, okay. Should have asked this question. The third one there. What tells you that's a quadratic? Just looking at it. What did we look at in the first one? The x. What's the exponent of the x? The maximum exponent for the variable can be 2 and only 2. Okay, maximum exponent. It could have an x term there. This one doesn't. Okay. All right, 10 o'clock scholar. Okay. Well, I can't find you. Ryan, no, I know it's Ryan. I just can't find where you are in here. There you are. Yeah. You have to go all the way across the page, and it's real easy to get off a line. Okay. Now, these are examples of polynomial functions. What would be characteristic of any other polynomial function? And it has to do with those exponents. What do the exponents have to be? Positive whole numbers. Not real numbers, whole numbers. 1, 2, 3, 4, 5. You're counting numbers. That's the only allowed exponents you can have. That what make polynomial functions. Terms with only whole number exponents. Okay? So here's our definition of a polynomial function. We're not strictly talking about quadratics yet, but we're getting there. Let n be, and what did we just say? Non-negative, positive only, integers, whole numbers, okay? But non-negative integers are whole numbers. And these coefficients here, the n's are your positive numbers. These are the coefficients that go with those powers of the n. So if your x is n, a sub n goes with that. If x is 2, if the exponent is 2, it's a sub 2. If it's 17, exponent of 17, then a sub 17. These are your coefficients of the terms with that of that degree. That's all the a's are. They're the coefficients. They can be any real numbers in the world. They can be positive, they can be negative. They can be fractions, they can be decimals. They can be rational, they can be irrational. It doesn't matter. Any real number in the world, the a's. The n's are only non-negative integers, positive whole numbers. Okay? Now, there's one exception, though, for your a's. Your a sub n, that first one, the one that goes to x sub n, it can't be 0. Okay? It can be positive, negative, fraction, decimal, rational, it just can't be 0. The others can be 0, any of them, or none of them, or whatever. A sub n cannot. And here's why it can't. Because we want this to be a polynomial, a function of x of degree n, and if that a sub n was 0, this would be degree n minus 1. So for the second part of this to be true, the a sub n can't be 0. That's the only restriction. And that's how a polynomial function looks. Your exponents are all whole numbers. Okay. Polynomial functions are classified by degree. This would be degree n, because it's the maximum degree that you have here. The constant function, f of x equals c, what's its degree? Where's your x here? Yeah, the x isn't 1. The x has x to the z, its degree is 0, so that means it's 1. This has degree 1. The exponent is 1. This doesn't even have 1, so the x is degree 0. Okay? Because x to the 0 is 1. Okay? So, now, they say that f of x equals 0 doesn't even count as a polynomial. Some places say it does, some it doesn't. It really doesn't matter. It seems like if c was 0, that would also have degree 0, but they don't seem to think so. So this would be degree 1, as long as a is not equal to 0. I guess the reason they say c can't be 0, that is your a sub n, okay? And they said that can't be 0, so I guess that's the reason. In this section, we'll study second degree polynomials only, and those are called quadratic functions. So the maximum exponent is 2 alone, okay? You can have exponents of 1, but you can't have exponents greater than 2. All right. Now, are these quadratic functions or not? How about the first one? Yeah, maximum exponent 2. How about that one? What you think? It's a quadratic also. And the reason, when you square this, that's what it says to do, you get x squared plus 2x plus 1. Maximum exponent of 2. How about this one? It has a coefficient of 1/4. Is that a quadratic? Sure. It doesn't matter what the coefficient is. It could be any real number except 0. But the maximum exponent is 2. So this one has a negative coefficient. Can that be a quadratic? Sure. Maximum exponent of 2. How about this one? I don't see an exponent anywhere. Yeah, when you FOIL it, you get the first thing is x squared, and then all the other x's and numbers. Okay? So yeah, that's a quadratic as well. The squaring function is a simple quadratic function, degree 2. It's what we were calling the parent function of your quadratics. Okay. So here's the definition of a quadratic function. Let A, B, and C be any real numbers in the world except A can't be 0. The B and C could be, but A can't be 0. Then the function f of x equals ax squared plus bx plus c is called the quadratic function. That's what it's called, the quadratic function. Okay? Say it twice here. Now, does that look sort of familiar? That is what we used to call, when we set it equal to 0, we said it was the standard form for our quadratic equation. Okay? That's not going to be our standard form for a quadratic function, though. We're always going to start with that, but we're going to change that later. We'll worry about that tomorrow, because tomorrow's another day. Okay. The graph of this quadratic, every quadratic function, as long as that a is not equal to 0, is a special type, and they call it a U-shaped curve. I call it a rounded valley curve, okay? Because a U tends to go straight up. It's not. It's rounded at the bottom. That's why they say U-shape, but it goes up like that, okay? It's called a parabola. Parabolas occur in many real-life applications, especially those involving reflective properties, satellite dishes, flashlight reflectors, that kind of stuff, okay? Here is the characteristic why they said that of a parabola, okay? And we're not going to deal with this at all. But every parabola has a point in it we call a focus. And the characteristic of a parabola is if you put a light source, a point source of light at that focus, then all the rays coming out are going to be parallel. And that's why satellite dishes are parabolic in shape. Because what they're doing, they're receiving the rays as they're coming in because they're so far away, basically parallel, and then focusing on that little device that's sitting there, that's sitting at the focus. And that focuses all those rays onto one point. That gives you a good signal. Okay? So that's why a satellite dish is parabolic in shape. Flashlight reflectors, you have the bulb sitting on the focus, and then that reflector behind it, that sort of silvered mirror-looking thing, that's a parabolic shape, so your beam comes out very close to parallel. Now, why it's not totally parallel, the bulb is not a point source. It's a little bit bigger than a point, so you get some fuzziness on the edges. Another thing that is, any of you have or drive a car? Notice the mirror, the reflector behind your headlamps, parabolic in shape, because the beam comes out close to parallel. Okay? That's what you want it to. The bulb is sitting right on that focus. And we're not going to deal with the focus, but that's why they mentioned this. That's not the only place they occur in nature. Okay? Any of you ever played basketball? Okay, possibly. Okay? When you shoot a basketball, what's the shape of the path of that basketball? A parabola. Every time. Except a dunk. Okay, that would be just going straight down. Okay. I don't dunk, okay? I don't dunk. Okay, never mind. We won't go into that. Okay. I can't dunk. Okay. The golf ball, baseball, everyone, even a pitcher firing a fastball, is going to have a little bit of curvature in it. It's going to be a parabolic shape. Every projectile is going to be a parabolic shape. Okay? Now, all parabolas are symmetric with respect to a line, and we call that line the axis of symmetry because it's symmetric on either side of that. Okay? Sometimes we just say it's the axis of the parabola. Okay? When I say AOS, that's axis of symmetry. Okay? The point where the axis intersects a parabola is always going to be called the vertex of the parabola. Okay? The axis is this point that everything's symmetric to. There's one point that really isn't. It's that one because it doesn't have a point on the other side. That's called the vertex. If the parabola is going like this, there's the vertex. Okay? And you can probably tell me right now, even though we're not talking about it yet, this is also called the minimum value of that parabola. And that's called the maximum value. We're going to get to that a little bit later in this section. Okay? But this is what your vertex is. It's the point where the axis of symmetry intersects the parabola, and it's always going to be the minimum or maximum, depending on which way it's doing. Now, this one happens to be opening upward. This one's opening downward. Can anyone tell me how you could look at the equation here and tell me whether it's going to open up or down? Okay? You look at the leading coefficient, that A. If that A is positive, it's going up. If it's negative, it's going down. Because the term that dominates this is the squared term. Because if you square anywhere sort of big number, like 10, square 10 and what you get? 100. Okay. That's going to dominate. It doesn't matter if this is B times 10. This is going to be A times 100, so that's going to dominate that. So that's going to determine. So if this A is positive, those numbers are going to be big. The problem is going to be big. If A is negative, though, the large numbers are going to be very, very negative. Okay, so it opens down. So all depends on the sign of the leading coefficient. Okay, the A. All right. When the leading coefficient is positive, the graph of that is a parabola that opens upward. When the leading coefficient is negative, the graph of that looks just the same, but if that A is negative, it opens down. Now, the simplest type of parabola, I sort of disagree with this a little bit. We already talked about it. The simplest type of parabola is when A is equal to 1. Okay? A is equal to x squared. F of x equal to x squared. That's our parent function. Remember the one we talked about before. Put an A there, and it's a little more complicated, but still not much. Whatever that was, you just multiply it by A. If that A is positive, it's going to be like this. If it's negative, it's going to be like that. A positive one is going to be like this, a negative one is going to be like that. And then we'll talk about, and we've already talked about it. Okay? What does that do? You're multiplying by the y value. You're doing a vertical stretch if A is large, a vertical shrink if A is small. A negative flips it across the axis. Okay? We already did that back when we did our, what do we call it? Horizontal vertical shifts, horizontal, we had a name for that. It's when we monkeyed with them anyway. Okay. The shifts are adding and subtracting and multiplying as it stretches it. The graph of a parabola whose vertex, remember that A, x squared? Its vertex is always 0, 0. How do we know that? Put a 0 in for x, your y is immediately 0. Okay? Any other x you put in there, it's going to be either a positive number if A is positive, a negative number if A is negative. Because whatever you square it, it's going to be positive when you multiply it by positive or negative, it's going to stay positive or flip it to be negative. But it's always going to be the vertex is 0, 0, no matter what the A is. Okay. Now, if you have a plus something BX, a plus C, yeah, that moves it. That's your shifts and your other things. So this is only going to be at the origin. I mean, the vertex is only going to be at the origin. All right. When sketching the graph of that, it's helpful to use the parent function, oh, surprise, surprise, as a reference. So usually we'll draw that first, and then depending on what the A is, if A is positive, it's going to keep going upward. But if A is a large number, it's going to stretch it vertically. If A is a small positive number, it's going to shrink it vertically. If A is negative, it flips it over, and then the size of A, absolute value of A large, it's going to be a stretched, shrunk, inverted, and a small negative A would be a shrunk function. Okay. So use that y is equal to f of x as a reference. So let's do this. Example 1, how did this happen? Okay, there we go. Example 1, sketch the graph of each of the functions, compare it with the graph of y is equal to x squared. Now I'm going to cheat a little bit. I'll look at that, and what are my a's here? 2, and they're both positive. So I know this thing's not going to go negative anywhere, right? Okay, so I'm going to draw, let me get my pen set up, back to black, okay. I can do my x-axis way down there. Now, let's just tick off a few points, 1, 2, 3, 4, 5, 6, 7, I don't need that many, 2, 3, 4, 5, 6, 7, negative, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, we won't need, well, we'll probably need most of those. Okay. What do we graph to begin with to compare these two? Parent function, x squared. So give me the points for just x squared. I'm first going to do f of x is equal to, well, let's not call it f. Let's call it h of x is equal to x squared. Okay? Give me some points for that one. 0, 0. Help me. When x equal 1, what's your function? What's the y? It's easy. When you square 1, you get 1. Square negative 1, you get what? 1. Square 2, you get? Square 2, help me somebody. 4. Square negative 2, you get? 4. Square 3, you get? 9. Okay, somewhere out here. And square negative 3, you get? 9. Everything else is going to be off scale. Okay, so here is approximately what that parent function parabola looks like. Something like that. Okay? Yeah, we used to that, aren't we? Now, what's the axis of symmetry there? The axis of symmetry. Everything symmetric about it. The y-axis. Now, we ought to have a better way of saying it than the y-axis. Okay, here's how we say it. What is x equal to everywhere on the axis? Say again? X equal? X equal? On the y-axis? What's your x value? Every point on the y-axis, what's the first of the ordered pair? 0! Okay, where x equals 0. Okay, so that's the axis of symmetry. AOS, axis of symmetry, is where x is equal to 0. Now let me give you a hint here, folks. What's the vertex of this one? The vertex? It's the ordered pair 0, 0. Okay? here's a hint. X equal the first one, that's always going to be your axis of symmetry. So if you knew the vertex was 0, 0, x equals 0 is your axis of symmetry. If that vertex is over there at 1, 3, axis of symmetry, x equal 1. If it's over here at negative 1485, the axis of symmetry is negative x equals negative 14. That first coordinate tells you what the axis of symmetry is. It's x equal that number. Okay, that's beside the point. We'll get there later. Let's do f of x. You need to give me a color for it. Which one? Purple. Okay, we're going to choose purple for, there we go. This one will be in purple. Okay? How will we plot that? Give me an x. Give me 0. And what will be the value for f? 0. Okay, that sits right there. Then if you chose a 1, that would be 1, but you take a third of it, and that's only 1/3. Now, I take it we must be getting near the end, okay? Let's just do this quickly. That reduces it to 1/3. When you do 2, that would have been 4. 1/3 of 4 is 4/3. That's 1 1/3. And so would you get out of there? Okay. 1 1/3 would be right here, and negative 2 would be 1 1/3. Okay? When x equals 3, it would have been a 9. 1/3 of 9 is 3. Okay? Negative 3 would be that. See, the axis of symmetry is still there. The next one would have been a 16. 16/3 is 5 1/3. 4, 5 1/3. That would be out here and over here. You get the general idea. Here is your new parabola. You sat on it. It's a vertical shrink. Okay? If you did the 2 here, 0, 0, 1, 2. Whoops, we need a new color for it. What color for that one? Red. Okay? 1, 2, negative 1, 2. 2 would have been 4. You double that, and you get 8. Somewhere up here. 4, 5, 6, 7, 8. Here and here. Okay? And then tripling would have gone off scale. Okay, and 0 is still 0. That was a pretty ugly looking one. That's a vertical stretch. It's not that funny. Okay, vertical stretch. Okay? So there are your two functions for example 1. That, by the way, was on page 116. By the way, there is a checkpoint. Please do the checkpoint as soon as you can after class so you can follow that. Okay? Now, we'll begin next time with, let's begin with example 1. We won't redo it all. Remind me not to do it all. But next time, actually, what are we doing? The test, okay? On Tuesday, we have the test. And then on Thursday, we'll come back to example 1. And we won't do it all, but we'll do it fairly quickly. We'll do the book part of it. All right. Did we do enough to do any homework exercises? Let's see. It's a pretty short section. I think you can do, okay, I would do 5 through 8. Only 5 and 7 have answers in the back, but it should be pretty easy to, well, no, forget about it. We'll do it later. No new homework problems here. Just focus on the test. Just focus on the test. All right. All right, remember, what can you bring with you to the test? A formula and equation sheet, scratch paper, and calculator. Okay? You can have it all. I'll need your quizzes in, okay, before you can take the test. Or you have to ask me to give you a politely. Yes. So please get quizzes in. And those other two tests, too, the other 4.
Yeah, I had a job interview last time.
Oh, okay.
Thursday I had 4. I've got a school right now, so
Okay.
it's hard for me to be here all day.
Okay. All right, good deal. What's that? Oh, okay.
On my phone.
How many questions are on the test? This test? It's about 20. I don't remember exactly. It's about twice the length of the quiz. The quiz is 10, about twice that. The first page is going to be covering most of the same material as this, and then the second page would be the newer material. Approximately. I mean, it may spill over a little bit longer. All right, good deal. Thank you. Okay, let me end this mess.